Hello and good morning, student. Today we are going to study class 12th chemistry. We will start from chapter 1. The name of chapter is solid state. We are very familiar with this, but we have to study some more interesting fact about the solid. As you know, anything which has a fixed shape, size, volume, density, rigidity, structure, arrangement in our surrounding termed as a solid. But here we are going to define the solid in another manners. Solid are the chemical substance which are characterized by definite mass, shape and volume, rigidity, high density, low compressibility. The constituent particle of solids are atom, molecule or ions. These are closely packed and held together by strong intermolecular forces. Now the question comes in our mind. Type of solids: crystalline and amorphous. We are very familiar with both these type of solids, but we need to know detailed about it. So here solid can be further classified into two categories: crystalline and amorphous. Crystalline and amorphous. Crystalline solids constituent particles are regularly arranged. It means they are arranged in a particular way. They are arranged in a row, in a column, in a particular arrangement. Possess sharp melting point. All the solids have a sharp melting point, sharp range of melting points. It means that that very solid start melt on a particular melting point. In case of amorphous, constituent particles are not arranged in a regular manner. It means they are arranged irregularly or randomly. Do not have sharp melting point. In case of crystalline, they are anisotropic in nature. Anisotropic is a property in which if we draw a plane, a line, the arrangement of particle followed by a symmetrical pattern. If we draw a line, axis or plane along the crystal. Amorphous are anisotropic in nature. If we pass a X-ray or diffraction or draw a plane, in this case we have different constituent in different point. The constituent not remain same. Now crystalline definite geometry shape, and in case of amorphous no definite geometry or shape. Crystalline have long range order. Range order means they have long range order. Variety of crystalline is available in nature, and amorphous has short range order, means all the amorphous that are mostly come in the same context. So here are the difference between amorphous and crystalline. Note it down. This one, particles are well arranged in a particular pattern. If we draw a line from this plane, from this axis, or in any manner, we find that the arrangement of particle is same. But in this case, if we draw a line from here, we have only 3 particles, but diagonally we have so many particles, but the particles are quite apart from each other and randomly oriented, randomly arranged. Now we are going to discuss the isotropy and anisotropic properties. Two solids which have some same physical properties. For example, electrical resistance, refractive index, and so different value when measured in different directions in the same crystal. This property is called anisotropic property. Crystalline solids are anisotropic in nature. Different type of solid. We are going to discuss about the different type of solid. What are the different type of solid? Solids may be further categorized on the basis of their composition or intermolecular forces holding between them or the operating between the constituent or particle of the solid. So solid further can be classified into 4 categories: molecular solid, ionic solid, metallic solid, covalent or network solids. Network solids. Network solids. Molecular solids further classified is divided into 2 groups. Basically these are 3: non-polar, polar and hydrogen bonded. Non-polar, polar, hydrogen bonded. These are the classification of solid, different type of solid on the basis of constituent particle. In case of molecular solid, constituent particle is molecule. Ionic, ions. And in case of metallic solid, the constituent particle is positive ions and in this case atoms. Means when the constituent particle of solid is atoms, it is called covalent or network solid. When the constituent particle positive ions, it is called metallic solid. And when the constituent particle is ions, maybe both positive or negative, called ionic solids, and the particle is molecule, then it is termed as a molecular solid. For example, carbon dioxide, H2O water, hydrogen bonded, non-polar CO2, and in case of polar, for example, CO2, CCl4, or in case of polar, here we can say HCl, HF, etc. These are the example of this. If we are talking about the ionic solid, we know that very well: NaCl, KCl, CaCl2, etc. In case of metallic solid, iron, copper, zinc, Ag, Au, and so on. In case of covalent or network solid, we must basically talk about SiO2, silica, quartz, silicon carbide, carbon यानी diamond, carbon in form of graphite, this. Now after study this type of solid on the basis of constituent particle, and their type we done with the example. Now we are going to discuss about the crystal lattice, the regular three-dimensional arrangement. The regular three-dimensional arrangement of the constituent particle in a crystal. The regular three-dimensional arrangement of constituent particle in a crystal is called crystal lattice. Crystal lattice. The regular 3D arrangement of constituent particles in a crystal in which each particle is represented by point called crystal lattice and points are called lattice point. Crystal lattice. The regular 3D arrangement of a constituent particle in a crystal in which each particles is represented by point called crystal lattice and points are called lattice point. So this is the definition of crystal lattice. Now we are going to define the unit cell. Unit cell. What is unit cell? The smallest fundamental fundamental repeated three-dimensional unit of a crystal lattice. The smallest fundamental repeated three-dimensional unit of a crystal lattice called unit cell. This is the smallest example of a unit cell, a portion of unit cell in which representation. Now if we extend this to this such that we have three axes, x, y and z. The angle between these three-dimensional representation we are going to discuss here the crystal lattice perimeters, characteristics of unit cell. So first again we have to draw a unit cell. This is our unit cell. X, Y and Z. The angle between Z and the side is A, B and C. A, B and C. The angle between B and C is termed as alpha. C and A is beta and A and B is gamma. Here we have crystal parameters. Crystal parameters is 3 side A, B and C, 3 angle alpha, beta and gamma. These are the crystal parameters. 3 sides and 3 angles. The total crystal parameters is 6. All the crystals can be explained on the basis of these 6 parameters. Now, with the help of these parameters, we are going to classify the unit cell or the type of unit cell. Okay, note it down. Okay, now we are going to classify the unit cell on the basis of these 6 parameters: side A, B, C and angle alpha, beta and gamma. Type of unit cell. Unit cell divided into 2 parts. First is primitives or simple. First, what is the first part? Primitives. Or simple unit cell. Second one is centered unit cell. Now, what is primitives? Or simple unit cell. The constituent particles are present only at the corner portion of the unit cell. The constituent particles are present only at the corner of unit cell, called primitives or simple. It means constituent particles are present in all the corner of a unit cell. This is the point. This is the point where the particle present. This is the point where particle present. So here, in case of a normal cubic unit cell, we find that there is a 8 corner and atoms are present at all the 8 corner. Constituent particle, they may be atom, molecule or ion. So atoms are present at all the 8 corner of the unit cell, called what? Primitives. Centered unit cells or non-primitives unit cell. Centered unit cell or non-primitive unit cell. Unit cell. Particles are present not only at the corner. Particles are present at not only at the corner, not only at the corners, but also at some other portions or positions. Now, centered unit cell further classified. Centered unit cell further classified into 2 types. They are basically 3 types: face centered, body centered and end centered. Face centered cubic, body centered, cubic and centered cubic. Face centered cubic is called FCC, VCC and this one is ECC, and centered unit cell. ECC. Okay, let's be discussed one by one by drawing diagram of this. If we're talking about the face centered, atoms are present at all the 8 corners as well as center of the face. As you know, a cube has 6 faces. We will draw it some large diagram. Here 1, 2, 3, 4, 5, 6, 7, 8. Atoms are present at all the 8 corners as well as center of the face. This one is what? This is the face. You know that cube has 6 faces. For 1, 2, 3, 4. If we number them, 1, 2 from upper portion, 2, this one is 3 and back portion is 4. Upper one is 5 and this one is 6. So one atom is here, one atom is here. Now the atoms are present at the center of each face is called what? Face centered cubic unit cell. The next one is body centered cubic, BCC. Here I am trying to draw the BCC diagram. Atoms are present at all the 8 corners as well as the center of the unit cell. It means what? 1, 2, 3, 4, 5, 6, 7, 8, and as well as center. This is the center point of the unit cell, cubic unit cell, and atoms are present at this point. This is called what? BCC, and this one is FCC, face centered unit cell. This one is body centered unit cell. Last one is end centered cubic unit cell. In case of end centered, we draw here end centered. Atoms are present at all the 8 corners as well as opposite of any two faces. If we take this from upper face and lower face, atoms are present at all the 8 corners as well as any two opposite face. This is what? ECC, end centered cubic unit cell. Now, after study these primitives, body centered, face centered, and end centered, we come at a conclusion on all the crystal in the universe is classified into the 7 crystal system. They are put on the basis of Bravais lattice. There are 14 Bravais lattices present in the universe or in the system. Bravais lattice. All the crystal system, there are 14 Bravais lattice, 14, 1 4, 14 Bravais lattice. All the crystal divided into these 14 Bravais lattices, and all the crystal present in the nature is part of this type. So here we are talking about the crystal system and unit cell and relation between the crystal parameters one by one. So unit cell, crystal system. Crystal system. We have 7 crystal system. Bravais lattice 14, and we have 14 Bravais lattice and 7 crystal system. Crystal system. Cubic, tetragonal, orthorhombic, hexagonal, trigonal, monoclinic, and triclinic. Triclinic. Cubic. Cubic has 3 unit cell, 3 type of unit cell. Tetragonal, 2 unit cell. Orthorhombic, 4 unit cell. Hexagonal, 1 unit cell. Trigonal, 1 unit cell. Monoclinic, 2 unit cell. And triclinic, 1 unit cell. If we add these 3 to 5, 4, 9, 10, 11, 12, 13, 14, total 14 Brebbius lattice, 3 cubic unit cell. It means in this simple BCC and FCC, BCC and FCC. In case of trigonal, simple or body centered, simple or BC, body centered. In case of orthorhombic, there are 4: simple, BC, body centered, face centered, and end centered, EC. BC, FC and EC. These are the 4 unit cell of orthorhombic. In case of hexagonal, only there is simple. Any primitives. Primitives, trigonal. In case of trigonal, primitives, any simple. And in case of monoclinic, simple and EC, and centered. And here is simple. So the total number of lattice is 40. If we are talking about the cube, if we compare with the perimeters A, B and C, bond perimeters, and angle alpha, beta and gamma. In cube, A equal to B equal to C, alpha equal to beta equal to gamma equal to 90. This is the parameters on which we are classified them. In cubic system, what? A equal to, all the sides of cube are equal, A equal to B equal to C, alpha equal to beta equal to gamma. In case of tetragonal, A equal to B but not equal to C, A equal to B not equal to C, alpha equal to beta equal to gamma, alpha equal to beta equal to gamma equal to 90 degree. It means this is a elongated A equal to B no, but not equal to C. A and B are equal. A equal to B not equal to C. Okay, this is what? Tetragonal. It means all the sides are not equal but all angle are 90. Next one is orthorhombic. In case of orthorhombic, A not equal to B not equal to C, and alpha equal to beta equal to gamma, alpha equal to beta equal to gamma equal to gamma, and equal to 90. In first 3 cases, we see that alpha, beta, gamma in all the 3 cases is 90, but A, B, C In first case a equal to b equal to c, second case a equal to b not equal to c, in third case a equal to b not equal to b and not equal to c. All the three sides are unequal and uneven. If we draw the structure, this one is a b. Let me draw the structure of orthorhombic. A B C, A B C, A not equal to B not equal to C, but the angle alpha equal to beta equal to gamma equal to 90 degree. Okay, just like a CPU in which all the three edges A, B and C are not equal but angle is 90. The next one is hexagonal. Hexagon, in case of hexagonal, A equal to B not equal to C, A equal to B not equal to C, alpha equal to beta equal to 90, alpha equal to beta equal to 90 and gamma equal to 120, gamma equal to 120. For example, should I erase it now? This is what? Hexagonal. A, B and C. A equal to B not equal to C. Alpha, angle between B and C, alpha, angle between A and C, beta, alpha equal to beta equal to 90 degree, and angle between B and A, gamma equal to 120 degree. This is what? Hexagonal. 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 Hexa means 6, gonal means side. You can draw it very easily, hexagonal. And now trigonal or rhombohedral, in which A equal to B equal to C. I have to clear more space. Rhombohedral or trigonal. 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 A equal to B equal to C. But alpha equal to beta equal to gamma not equal to 90. अल्फा बीटा और गामा बराबर होंगे लेकिन वो 90 नहीं होंगे. क्या मतलब हुआ इसका? कि आप इससे ड्रॉ कर सकते हैं. एनसीईआरटी बुक में ये 7 जो क्रिस्टल सिस्टम है आपके बेटरली जो है विद डायग्राम अच्छे से प्रेजेंट किया गया है एनसीईआरटी में. तो आप एनसीईआरटी से मदद ले सकते हैं यहाँ पे, ठीक है। इसके बाद मोनोक्लिनिक नेक्स्ट है हमारा। इसके एक ही होते हैं, हेक्सागोनल में एक ही होते हैं, जो हमने अभी रिप्रेजेंटेशन बताया था हेक्सागोनल का कि ये कैसे होते हैं, प्रिमिटिव्स होते हैं, यानी ऑल द एटम्स प्रेजेंट एट ऑल द कॉर्नर्स। इसके बाद आ जाता है आपका ट्राइगोनल हो गया, रोम्बोहेड्रल हो गया, ट्राइगोनल हो गया, और फिर अब बच गया मोनोक्लिनिक। मोनोक्लिनिक में क्या होता है, मोनोक्लिनिक में क्या होता है, ए नॉट इक्वल टू बी नॉट इक्वल टू सी। ए बी सी जो है वो आपस में बराबर नहीं होते हैं, लेकिन अल्फा इक्वल टू बीटा इक्वल टू 90 एंड गामा नॉट इक्वल टू 90। नॉट इक्वल टू 90 मतलब ये लेस देन और मोर देन 90 होगा, लेकिन 90 के बराबर नहीं होगा। इसके बाद है आपका ट्राइक्लिनिक। ट्राइक्लिनिक में भी वही है, ए नॉट इक्वल टू बी नॉट इक्वल टू सी। ट्राइक्लिनिक में क्या है, ट्राइक्लिनिक में ए नॉट इक्वल टू बी नॉट इक्वल टू सी, अल्फा नॉट इक्वल टू बीटा नॉट इक्वल टू गामा नॉट इक्वल टू 90। ये थोड़ा सा एक जो है ये यहाँ पर अलग है इसमें कि अल्फा बीटा और गामा भी आपस में बराबर नहीं होगा, और ना ही कोई भी साइड इसके जो है वो आपस में बराबर होंगे, ठीक है। तो ये तो था आपका ब्रेवियस लेटिस के बेसिस पे। अब इसके बेसिस पे क्या करेंगे हम कि किसी भी जो यूनिट सेल है उसके अंदर कितने एटम है वो कैलकुलेट कर सकते हैं, जो कि हम अपने नेक्स्ट वीडियो में कैलकुलेशन ऑफ एटम इनसाइड द यूनिट सेल और रैंक जो है हम आपको निकालने सिखाएंगे। थैंक यू एंड हैव अ गुड डे।